Hey, good afternoon. Welcome. I'm Kimberly Blackman-Kahn. I'm the director here at the Ignite Hub. I'm here with Anthony, our lab coordinator. Welcome to the Future of Tech session for October. The year is flying by, so we're glad that you're here today. Today's topic is very exciting. It is about space, and the Hub team around this time last year, maybe it was cold. I had a coat on, so I'm trying to remember the weather. But we were invited to a space summit down at the Embassy of France, and this is where we met our guest speaker. So fascinating, blew my mind about space and all the opportunities that we have. So I'm very excited to introduce our guest speaker today, Elvert Gardner, Strategic Account Manager at L3Harris, is leading space strategy and development and business capture initiatives. With over 30 years of experience in space strategy, policy, and national security, Elvert aligns corporate strategies with legislative and regulatory trends in space and artificial intelligence. In addition, he serves as an adjunct professor of space policy and security at Georgetown University. Previously, Elvert was a colonel in the U.S. Air Force and later in the U.S. Space Force. He served as Director of Space Policy and Strategy at the United States Space Force, leading the development of the U.S. Space Force commercial space strategy. He holds multiple advanced degrees and is completing his doctorate in defense and strategic studies, focusing on space deterrence and arms control. Elvert is a combat decorated veteran recognized for his leadership and contributions to the defense sector. So without further ado, let's welcome Elvert, our guest speaker today.
Thank you very much. Next slide, please. So thank you for the introduction and thank you for the opportunity to be here today. I'm always excited to have an opportunity to talk about my passion, something that I've done for the last 30 years of my life, which is work in the space sector in various different capacities that you can see there. On the national security side, that's military. I've also done some commercial work, and I've also done a lot of policy work. I dabble in space economy a little bit. And as was mentioned, I also teach on space policy and security. So I've had an opportunity to do a lot of cool things into space, which is something that really I'm passionate about. I want to take you back in time just a little bit to talk a little bit about how did I get here. So I like to, if you're into comic books and all that, I like to talk about Marvel Comics a lot and talk about heroes. And if you follow heroes a lot in Marvel Comics and all that, every hero has an origin story. So let me share with you a little bit of my origin story. My origin story basically starts with when I was a young child, my mom would send me down to Texas to stay with family in the summer. Everyone's probably familiar with the whole idea of going to see family members in the summertime. My uncle, who lived in San Antonio, Texas, was a drill sergeant at Lackland Air Force Base. And so I would go see him in the summers. He would take me on the base and I'd watch the troops walk around and do their marches and maneuvers. And then in the afternoons, we'd go sit out on the flight line and I'd watch planes take off and land. And I was hooked at an early age on technology, on airplanes, and on the Air Force. So fast forward, the first opportunity I got a chance when I went to Tuskegee University. The first chance I got, the first thing I did when I got on campus was I went to ROTC and I signed up. And the rest, as they say, is history. I've spent my career doing everything from working with ICBMs to working with various satellites, doing space strategy, policy, all those cool things. I've had a lot of fun along the way. And so that's what brings me to today, where now I'm sitting on 30 plus years of experience working in technology, specifically in space. And so I'm going to use that today and talk a little bit about that. And then I'm going to try to make sure that I save plenty of time for questions because I really want to hear from you what's on your mind and be able to share whatever I can with you that might be useful. Next slide. So we'll talk about a range of different things. Next slide. So I want to start off with a question. Can anyone tell me where space begins?
Isn't the most commonly accepted theory is the Big Bang Theory, which is still pretty much a bit on the fuzzy end?
Yeah, so that is a common theory on how space started, if you will. But in terms of physically where it is, can anybody tell me if I go up, when do I hit space? Anybody? Let's go ahead and do one build, please. Can we do one build on the slide? So I'll give you a visual to look at. Anyone want to take a look at this and take a guess at where in there?
The exosphere?
Good guess.
Around the Kármán line?
Around the Kármán line, yes, absolutely. So let's go ahead and build this out a little bit. One build there. The Kármán line is generally accepted as where space begins. It's 100 kilometers above the Earth, 62 miles. Now you'll notice that it says generally accepted, and there's a reason why it's in quotation marks. Next build, please. So the question becomes, why would it be generally accepted? Next build. Anyone recognize that?
Once had like one of those spy cameras just pop down.
Right, right. So if everyone remember the Chinese, the big balloons that the Chinese were sending and they were loitering over America?
Mhm.
That's one of those. The reason why this idea of where space begins and ends matters is because in the policy world, in the treaty world, if something is in our airspace, there are different rules and laws and conventions that say what's okay. If a balloon, for example, owned by someone is loitering over the United States, that's a violation of our sovereign airspace. But if I say, no, 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 it's in space, I can actually travel over your country because different rules and laws apply. Satellites from other countries travel over the United States all the time. And it's okay. And so this is one of the reasons why the definition of where space begins and it being only generally accepted is important. So in the policy world that I live in from time to time, we have food fights over trying to define things because words matter and definitions matter. So let's move forward. Yes. I don't remember the specific altitude, but I do remember it was in our airspace, not in outer space. And so the airspace rules apply, which meant that we were within our rights to shoot it down. If, however, it had been technically in outer space, beyond the Kármán line, then shooting it down would have been considered an act of aggression. So again, that's why that line matters, and that's why having an international community that agrees that, yes, that line is the line that we all agree on, that's why it matters. Next slide. So for our purpose today, I know many of you are here for different reasons. I want to quickly give you a little bit of understanding on space. When we talk about space, we tend to divide it into a couple of different categories. And I'll go into these in greater detail in the next slides. But for our purposes today, just looking at the left column, there's civil space, and then there's commercial space, and then there's what's called national security space, which can then be further divided into military and or intelligence. I'm going to go into those in greater detail, but I want to make sure that everyone has a baseline understanding. When we say space, it can mean many things. If you are interested in space, if you're interested in careers in space, that also can mean many things. You can work civil space for NASA, you can work commercial space for any company that's out there, including L3Harris, or you can go work with US Space Force. And I was having a conversation earlier with someone about that. Army also has space people there. So, and so do the other services. So different sectors to understand. Next slide. Okay, on the commercial side, what's important here to understand is there's a range of different things and capabilities that are happening in commercial space. Communications capabilities, there's launch capabilities, there's also data analytics, artificial intelligence, remote sensing. Remote sensing is this thing where we basically have satellites that have imaging capabilities in space looking down at the Earth. That's what we refer to as remote sensing or Earth observation. And then finally, you see over here, you see SDA, space domain awareness, and in-space servicing. The in-space servicing thing is a new trend in space that's very exciting. This is the idea of taking satellites and having satellites actually go up and rendezvous with another satellite to refuel it, to repair it, any of those kind of things. So if you're driving down 495 and you get a flat tire, you can call someone and get help. And AAA will send a tow truck, and the tow truck will come and they'll give you a new tire, or they'll, fix your battery or give you some gas if you ran out of gas. We don't have that capability today in space. When you run out of gas, that's it, game over. Everything else on the satellite may be operating just fine, but now that you're out of fuel, that's it. Things are changing. Now we're at a point where we're building satellites expressly for the purpose of going up to refuel another satellite or to repair another satellite. So these are some of the cool things that commercial companies are doing. Next slide. Yes, ma'am.
But connect to the Starlink too.
That's right.
Is
That's
that
right. In fact, I just flew out to LA last week, and I connected to Starlink while I was on the plane. That is an option on some aircraft now to have Starlink for your Wi-Fi. So we can talk more about Starlink, but Starlink basically is a series of satellites that provide you with broadband internet connectivity on the ground and in the air. You bet. Next slide. So we talked a little bit about commercial. Let's talk about civil. So with civil space, this is NASA. This is the FAA. This is the Department of Commerce. These are some of the governmental organizations that are responsible for civil space. So when you think civil space, think government-owned, non-military. The most prominent one is NASA. NASA's signature program right now is Artemis. The Artemis program is the program about getting back to the moon, building out all the lunar landers and all of those things, which we'll talk about in the next slide, and then also making our way to Mars. We're gonna go to the moon first and then go to Mars. So this is one of the signature programs that are part of civil space that NASA's doing. NASA also does all kinds of science and exploration pieces. And then there's also a lot of things happening in low Earth orbit, which we will talk about in just a second as well. Next slide. So from a business perspective, it is important to recognize that space is not just cool. It is something that is generating a lot of money for a lot of people. The United States relies heavily, very heavily on space to generate a lot of capability and a lot of money as a result of that. And as we look to the moon and going back to the moon, the idea is to have a permanent presence on the moon. Do lunar mining for various rare elements, elements like helium-3, and there are several other elements that they're looking to find on the moon, and be able to harvest those elements, some of which they'll bring back to the Earth, and some of which they'll simply use there for purposes of raw materials for going out to Mars and going out to other places. So a lot of money to be made. Another aspect of that beyond the mining is, how do we get there? Well, somebody's got to build the rockets. Well, there's a space company for that. Somebody's got to build the suits for the astronauts. There's a company that's going to do that. We need a lunar lander. Somebody's got to build that. And so because we have these goals and aspirations to do cool things in space, there's all kinds of opportunities for companies to come on board and actually participate in these programs. And so that's one of the cool things about space is that it generates revenue and it creates jobs. By going to the moon, it's creating a lot of jobs for a lot of companies. Next. Continuing on with the idea of economy, one of the new trends in space is this idea of what we have called proliferated LEO. And proliferated LEO basically is low Earth orbit. Those are the satellites, when I showed you that slide that had the different ranges, those are the ones at the lowest edge of space. And then you have some that are much higher than that. And so the trend now is producing lots and lots of satellites in low Earth orbit. You brought up Starlink. Starlink is an example. SpaceX is pushing out tons of satellites, hundreds of satellites, and the constellation will be around 2,400 satellites. That's a lot of satellites that will be distributed in low Earth orbit in the lower altitude, spread around the globe. And those satellites will do everything from providing imagery to providing communication like Starlink, and they will generate revenue. They will also do cool stuff like in-space manufacturing, which, think about that for a second. We're now on the cusp of a new trend emerging where we will actually build things in space. Rather than build things on the ground to take them to space, we will begin to build things in space and then use them in space. And so this is a new trend. And you'll see at the bottom of the slide, there's all kinds of cool things that happen in space. We're doing all kinds of science experiments with biological. Pharmaceuticals is a major area that is being developed in space using the zero gravity that's there. And then there's this thing called venture capital. So the companies that have money, that are looking to make money by investing money, are looking heavily at the space industry right now and pouring money into the space economy because they recognize there's money to be made. And so this is why there's so many space companies starting up now. And a lot of those space companies are right here in the DMV, a lot of it. So if you're interested in space jobs, there are many space jobs right here in the DMV. Next slide. So more trends. As we continue to move forward with space, one of the things that is a trend is satellites are getting smaller and smaller and smaller. We're learning how to do miniaturization and be able to take a satellite that used to be the size of a school bus, that's now the size of a small SUV or a small passenger vehicle. And in some cases, as small as that water bottle on the table. So we're making satellites smaller and smaller and smaller, which also means that when you launch satellites into space, now, because it's not the size of a school bus where I can only launch one because it's so heavy and so large, I can launch hundreds at one time. So a very cool and exciting trend. Sustainability, traffic management. As we're building out more and more satellites in space, someone has to be the highway patrol. Someone has to be the traffic cops. Someone has to be able to make sure that no two things are in the same place at the same time. When satellites are traveling at 17,500 miles an hour around the Earth, you don't want two things in the same place at the same time. A lot of damage, a lot of debris can result when satellites collide or when satellites break up. A lot of energy is being placed into building radars and building telescopes and building all kinds of sensors to help understand what's out there and where is it. And let's keep track of everything that's out there. So this is a growth area and will continue to be a growth area. Mega constellations is another area. We talked a little bit about this already. Building out huge constellations of hundreds and sometimes thousands of satellites, that's a new trend in space. And then finally, space-based Earth observation. Once upon a time, if I wanted an image from space, I had to go to the intelligence agencies, the National Reconnaissance Office, for example, to get an image of something. Now, I can order one from Maxar or from Black Sky. In fact, the next time you watch a newscast and someone is saying, oh, this is happening, and they show you an image, a satellite image, look up in the top left or top right corner, and you'll see something like Black Sky or Maxar. Commercial space companies are now putting satellites into space and taking images and then selling those, and that is their marketplace. So a lot of new trends are happening right now. Next slide. My bread and butter, where I've spent my adult life, is in national security space, military space. This is the cool stuff. All of it's cool, but I'm partial. So, anybody heard of Golden Dome? Yes? Okay. So if you have not heard of Golden Dome, there's a huge national program sanctioned by the president to build a missile defense architecture for America. It's called the Golden Dome for America. A major portion of that, a significant capability within that, is what's called space-based interceptors. This is the idea of placing things into space that can intercept an inbound missile long before it's on its way back down. Space-based interceptors give you the opportunity to catch it while it's on its way up, as opposed to when you only have a few minutes remaining and it's on its way down. So that's one of the cool things, one of the major things that everybody's talking about right now is Golden Dome. Then you have the National Reconnaissance Office that's doing all kinds of intelligence gathering. And then you have this other piece called National Security Space Launch. This is all of the launching of things. We used to rely on United Launch Alliance, and now we have this thing called SpaceX. And SpaceX is doing a lot of the launches. If you haven't paid attention, one of the cool things about what SpaceX can do is, one, they can launch a rocket and reuse it. 10 years ago, that was not a thing. You launched it one time and that was it. Now you launch it, come back, you refurbish it, launch it again, refurbish it, you launch it again. That saves a ton of money. And that brings the cost to launch something way, way down. And the reason why that's important is it makes it affordable to actually launch a satellite. If Montgomery College wanted to launch a satellite, they could have Montgomery Sat 101. They could launch it because it's affordable now. It doesn't cost billions of dollars to launch a satellite. You can launch it relatively cheaply because it's not as expensive anymore.
in space, or does it come here?
It comes back to the ground, and there's actually some videos that are really cool where you can see where they've launched a rocket into space, launch it, and then you jettison the satellite from there. The rocket itself falls back to the Earth, and it doesn't just fall back. You save fuel because it's meant to. Previously, it would fall back to the Earth and fall into the ocean. Now you guide it back to the Earth using the rockets because you save fuel. You guide it back and you can actually land it right back on the pad. And they have these things called, they call them chopsticks, where you've got this huge tower and these big arms that sit out like that. And the rocket comes down and it just sits right in between and just lands right in between the two chopsticks. It's really, really amazing. And it is something that is relatively new that we've not done before. Yes, ma'am.
Ability possible is it to, let's say, grow produce in space these days?
So I know that there's plenty of experimentation being done on produce and other bio type of things to figure out what can we grow, how can we sustain life in space. So there are experiments that are done on the International Space Station along those lines to identify what is possible. Because bear in mind, if we're talking about a permanent presence on the moon, you're going to need food. And if there is a way that you can grow that without the benefit of the organic soil that we're used to, then that's something that has to be figured out in order to be able to sustain life in space. You're going to have to be able to grow food.
One more question. Oregon artist named Robert Lang, if you don't mind me asking.
I do not dabble in origami, so no, I don't.
Okay, he also worked for NASA. So according to him, origami can be used to build all sorts of intricate designs like airbags, for instance, for cars. So,
Yeah, that's fascinating because one thing I can tell you is it is pretty fascinating to see how things fold up and then are deployed in space. When you look at a rocket, it's hard to imagine the fact that you could have this thing the size of a school bus and it just goes up there and then it just folds out and folds out and folds out and folds out and folds out. Next thing you know, you've got two giant solar arrays that are sitting out there, both of which are 100 feet long. So it's pretty amazing. I can see how origami could play in there because you have to figure out how to fold these things up to fit them onto the rocket. Next slide. So it's worth noting, I retired out of the Space Force. And Space Force is now 5.5 years old. So we haven't always had a Space Force, but sometimes people will ask, well, how did we end up getting a Space Force? Where did that idea come from? And newsflash for you, it's not a 5-year-old idea. The idea actually stems back several decades. When I was a young captain in the Air Force, we were writing papers about we should have a Space Force. And that idea gradually grew in momentum to something that was called the Rumsfeld Commission, which was a formal study that Washington, D.C. did under Donald Rumsfeld to study the feasibility of whether or not the space stuff that was in the Air Force should be pulled out and placed into its own branch, a military branch. So a study was done in 2001 to look at that. The challenge is in 2001, when they released the study, that was right before 9/11. So we got, I won't say distracted, our attention went in a different direction following 9/11. We weren't focused on, let's start up a new military branch. We were focused on the war on terror and all of those things that came after 9/11. Fast forward a few years, 2006, 2007, 2008, there was another commission. That commission said, yes, there's something there. There's some feasibility behind the idea of having space as some sort of space corps or some sort of separate service. But again, it really went nowhere. Some of the champions of the idea did not let go. So Congressman Rogers and a couple of other folks stayed on it and looked for the opportunity. And they finally got to a point where circa 2019 timeframe, they were able to get the ear of the president, then Donald Trump, first administration, and have a conversation to say, hey, we think we should have a Space Force. He took a good listen to what they said, and then he made the announcement we're going to have a Space Force. And so that is kind of the history, the origin story, if you will, behind the genesis of the Space Force. Is the idea was a long time coming, but as I like to say, particularly when I talk about space policy, is there's such a thing as a good idea, and then there's good timing. And when good ideas meet with good timing, that's when success happens. And so in this case, the idea of the Space Force has been around for a while, but it had not yet met with the right ecosystem to thrive. And when we got to the Trump administration part one, that is when he said, let's make this happen. And the rest, as they say, is history. So that is how we got a Space Force. Next. I won't spend a lot of time on this except to say that launch is on the rise. And what that means for you all is there's more and more and more activity happening in space across various countries. A lot of people are participating in space more and more. Part of the reason for that is because it's now more affordable. Next slide. The only thing that I'll mention here is there's a lot of money to be made. If you're interested in, say, starting up doing a startup business, and you're looking for the right industry to do your startup, this could potentially be the one. There are a huge number of startups that have gained traction and done well working in space. It is a huge economy, $613 billion in 2024 derived from space-based capabilities. We are en route to this being a $1 trillion industry by 2040. That's a lot of money. And when we get to the point where we're doing cool things like space mining on asteroids, there are some asteroids out there that are estimated to be worth $1 trillion by themselves. So lots of money out there. Next. So I believe this is just about my last slide. The only thing, there's a lot on this slide. I'll draw your attention to the bottom right. If you're looking to get engaged or follow and study space, there's a lot going on in space. And we tend to break things up into upstream and downstream. Upstream, I'm building rockets, I'm building satellites, I'm building the things that go into space. Downstream, I'm building the payloads and capabilities that provide the goods and services that you get back on Earth. So it's putting things into space or providing capabilities from space. Those are the two ways to look at it. There are a number of different places that you can go if you're interested in employment and job opportunities in space. Some of those agencies are listed there, the Pentagon, all across the intelligence community. NASA has opportunities, NOAA has opportunities, U.S. Geological Survey has opportunities, Department of Energy, Department of Labor, Department of Transportation, and on and on and on. Many, many opportunities to do all kinds of cool things. Most of those things are STEM, but not all. So let's say, for example, if for some reason you're not STEM inclined, if you're an engineer, you're good to go. If you're a computer scientist, you're good to go. If you're a data scientist and AI and all those things, you're good to go. We need all of that stuff. But if you're a policymaker, if you're a lawyer, if you're in insurance, all of these things also have a place, a prominent place in the space community. We need space lawyers. We need people who can do insurance to make sure that when you launch something, if something happens to it, you can get reimbursed for that. There's a number of different capabilities and backgrounds and skill sets that are relevant for the space community. Some STEM, many STEM, but not all. Next.
How possible is it for, let's say, a director like George Lucas to be able to make like a film, like a space film in space?
Well,
it would be expensive to make one in space. You'd be better off trying to simulate and make it look like it's actually in space. And there's been plenty of movies, as you can imagine, where that has been done. One of my favorites is Gravity, that George Clooney and Daniel Brand. That was really good. And there's a fantastic series called The Expanse. Several seasons, really good. It gets into economy, it gets into international relations, it gets into all kinds of different issues based on Earth, based on other folks. It's a fantastic thing. There's all kinds of cool stuff out there. So I want to leave you with a couple of thoughts. My career advice for you is this. First and foremost, you always have to begin with the end in mind. So whatever it is that interests you, whatever it is that fuels you, whatever your passion is, whatever your goal is, set your path towards that. And most importantly, write it down. It's not real until you write it down. You want to take dreams and make dreams into goals. And the way you do that is you make it tangible, you make it real, you write it down. And then you go find a mentor, or as I like to say, a team of mentors. Never settle on just one person being a mentor. Have a team of mentors. Talk to someone and ask them the question, how did you do it?
What are my opportunities? What kind of skills do I need if I want to do this? If I want to be here, what must I do? You need a team of mentors to help you along that path. And so my recommendation is make sure that you've established where you want to be, and then find a mentor to help you get there. The other thing is you want to make sure that you always stay informed on what's going on in whatever chosen field that you want to be in. Now that I'm on the business side as opposed to the military side, the term of art that I use on a day-to-day basis is business intelligence. I start my day by trolling through all kinds of media sources, trying to figure out what's going on in space business. That's how I start every day, so that I know exactly what's going on and I can fire off emails to my boss. Hey boss, this is happening. I'm going to find out some more about this, and this is relevant for us. You want to do the same thing. Whatever your chosen direction is, find what the relevant media sources are for that and troll through those every morning and stay on top of what's happening. And then that helps you align and be agile in case you need to pivot. And the final thing that I will say that's important from a career perspective is, depending on where you are, no matter where you are, there is someone who's just getting started and is further behind than you. So it's your responsibility to take all of the advice, all of the mentorship that you have received, and reach back and find someone and do what we call pay it forward. I had a successful military career because literally on day one, someone sought me out on the base and said, hey, come with me, we're going to lunch. Let me teach you everything that you need to know to be successful. And throughout my career, I had people who did that for me. A good mentor will help you reach your full potential and help you get out of your own way. You should also seek to be a good mentor and find someone who could benefit from the things that you have done well, the things that you have not done well, and give them that knowledge and expertise and help them along the way. So that's my advice. With that, I'll stop because I want to save time for questions from each of you on all the cool things that space offers.
Thank you. Ooh, I'm going to come up here to the front. Thank you so much. Wow, that was incredible information. Now, you know, when we went to the Space Summit, I was like, wow, there's a whole world out there that I had no clue, and it really is the future. So thank you for breaking it down for us and really helping us understand what's coming towards us. So now we're at the part of the program where you get to ask questions, and we have been asking questions throughout, and I know there are some questions in the chat. So maybe we can start with those, and then for those of you that are here in the room, just raise your hand and I'll run over with the microphone.
All right, we have a couple questions here in the chat. First one from Hamilton Facts. This was earlier in your presentation. Could you define what ICBM means for the audience?
Yeah, my apologies for using acronym soup. That old habits die hard, and when you're in the Pentagon and in the military, you use acronyms all the time. ICBMs are intercontinental ballistic missiles. So my very first duty assignment was in a place called Grand Forks, North Dakota, and I was responsible as an operator for going down in the hole and being the person who, if called upon, would launch our nuclear missiles towards whatever destination they needed to be launched towards. Those specific types of missiles are, the category of missiles are called intercontinental ballistic missiles because they travel a certain distance, continent to continent. They're known as ICBMs.
And this person had another question. Does Space Force have a branch that includes bad weather in their strategy?
I'm not sure I'm following the question, but let me say this. Weather is a part of what is provided from space, and weather is a part of what we need to understand in space. A common misperception about space is that space is just this featureless void, a vacuum. Untrue. Technically, space has terrain. It has features. It has radiation. It has extreme cold. It has extreme heat. It has gravity. And there are places where the gravity is stronger, and there's places where the gravity is weaker. So there are all kinds of aspects to space, and there's also space weather. Yeah. Solar flaring is a feature in space where you have coronal mass ejections, if you will, plasma spewing out from the sun that causes impacts even here on Earth in terms of your radio frequencies and the like. So there's a lot to space weather.
And we have one more question in the chat from another individual. As a public health practitioner and IT professional, I'm interested in exploring how emerging technologies, particularly space and satellite innovations, can strengthen public infrastructure, digital equity, and global health systems. How is NASA or the broader space technology sector leveraging satellite data and AI to advance public health monitoring, environmental resilience, and emergency preparedness on Earth?
A lot to unpack there. Many questions embedded in that. Let me try to tackle as much of that as my memory can hold, and help me if I miss a certain piece of this. Sure. Okay, so first on the public health side, NASA's doing a lot of experiments in a zero gravity environment on pharmaceuticals, trying to understand and build different compounds and the like, so that they can be used on Earth. That is one area. When it comes to AI, there is a significant push right now to figure out the proper way to adopt AI for space-based purposes. Bear in mind one key way of looking at space. Satellites themselves essentially can be thought of as routers in the sky. They exist to push, to receive, to disseminate information, data, which means you need data scientists, you need data analytics, which means also, because you have such a huge volume and sometimes you need things very quickly, you need to introduce automation and you need to introduce artificial intelligence so that you only get the data that you need versus the data that you don't need. Because as I like to say, It's not about the data, it's about the information. And the difference is data is all the things. Information is the part of the data that I need so that I can make a decision. Because at the end of the day, that's why we need the information so that we can do something with it. There's a lot of energy being placed into how do we use artificial intelligence to help support the information that is flowing through space for public health, for purposes of infrastructure, for many different applications. Did I miss any particular part?
Other than public health, there was environmental resilience and emergency preparedness.
Great. Environmental
Resilience,
and
emergency preparedness.
okay. So because we have remote sensing can do some really cool things like look at temperature of the ocean. It can look at a beachfront and figure out whether or not that beachfront is eroding. It can look at a field of soybeans and tell you whether or not you're en route to a drought. It can give you all kinds of information that can help with farming. It can give you all kinds of information that will help you accumulate data on trends of weather. Every time there is a hurricane, you always see the big funnel clouds and all that. Satellite-based imagery looking down, showing us the size and strength of that particular hurricane. So there are a number of different applications, and there's constant research and development on how to develop additional applications or introduce additional artificial intelligence and algorithms to refine the information that we receive. Yes, ma'am.
Hi, thank you. My name's Nicole, and I want to first say thank you for just a pretty awesome presentation. I learned a lot that I didn't know. I also appreciate you sharing your origin story, I guess you would say. My interest in space started, I guess say, middle school, high school, just an interest in stories like Roswell and things like that and the possibilities. I at one point thought I wanted to study astronomy, but I didn't follow it through, so I'm glad you followed your interest through. But my question revolves around, I guess, the public's input or influence that all these space activities are taking place. So if we have satellites that thousands of them are in space and there's surveillance and all these things happening, some folks can be a little weary about what images are they taking? What's my privacy? What's my protection? What's out there of me and my life that's going on in space? What are, I guess, the regulations of all these competing businesses and countries that are in space? What can we as the public know about what's going on, and what, I guess, influence do we have or rights do we have to what's happening in space?
Excellent question. Thank you very much. So you mentioned the R word, regulation. So there are a number of different regulatory agencies. Department of Commerce has a role, and the FAA has a licensing role. And there are another Department of Transportation has a key play, and then there's the FCC that has a role. Internationally, there's the International Telecommunications Union that has a role. Internationally, there's also a number of different conventions, if you will. There is the Committee on the Peaceful Use of Outer Space, COPUOS. So a number of different organizations and agencies exist to do a number of different things. Define what is okay and acceptable. Norms of behavior is what we call those. And try to establish those domestically as well as internationally. There's also the idea of you can't just launch something into space and do whatever you want as company X, which I think gets to some of your question. If I am the Acme Space Company and I want to launch something, I need to go to the FAA and get a license to launch it. If I want to transmit on the RF spectrum, I need to go to the FCC and get a frequency assigned to me. If I'm going to put this in a specific place in geostationary orbit, I need to go to the International Telecommunications Union to be assigned a specific orbital slot. So there are some rules and guidelines out there. There aren't enough, but there are plenty. And one of the things that's really important is we have this thing called the Outer Space Treaty, which was signed back in 1967. And the Outer Space Treaty provides some guardrails and guidelines on what is okay in space. One of the things that's important is if I'm the Acme Space Company, whatever I do in space technically is a national thing. If I do something bad in space, it's not a reflection directly on my company so much as it is a reflection on the United States, because the United States allows me to be in space to do the thing that I want to do as a private actor, but it's never completely private. It's never unregulated. I am doing things and I bear the burden of what we like to say is flag bearing. That satellite is a US satellite. It's privately owned, but it's technically under the auspices of the rules and regulations that the US has decided are appropriate. And so those are the guardrails that are out there. If you're looking to express concerns, the Department of Commerce has traditionally, when it's talking about regulation, had open forums that the public can attend in order to be able to say, I am concerned about whatever it is that you're concerned about. Would you please take that up or factor that into the regulations that you're considering? What I will also share is when it comes to regulations, there is a balancing act that happens from year to year. Sometimes we lean more heavily onto regulation, depending on the administration. And sometimes we do what's called a light touch, where we do less regulation, again, depending on the administration. So it ebbs and flows how many constraints are in place at one time. Oh, lots of questions.
I'll make my way around.
Oh my gosh, I have I have several questions, but I'll just ask one for now because I know several of us want to ask too. So I know like a lot of my peers, my students, classmates, even coworkers, they're confused when I talk about Space Force versus NASA because of course NASA, there's space exploration, there's research, but Space Force is mostly defense and policy. So what do your students find most surprising about space policy and security?
Most surprising was the question? I think what I try to impress upon my students is that no good policy fails to have a dark side to it. And I'll give you the example that I give to my students. I give this example on day one of my class. It is my policy to give every one of my students on day one, $100 cash. How many people think that's a great policy? Go ahead. In this room right now, how many of you think that's a great policy? If I'm going to say, thank you for being here, I'm going to give each of you $100. Good policy? Yes? 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 Okay. So everyone's saying yes. I imagine online they're like, hey, me too. All right. So that's the policy. The policy is I'm going to give everyone $100 for listening to me talk. Then I'm going to go home and I'm going to say, hey, honey, guess what I did today? I gave away a bunch of our money because I thought it would be fun. Now, what have we learned in this? She's not going to be happy because she's like, I don't want you giving away our money. So the takeaway from that is a well-intended policy in the eyes of one stakeholder is not necessarily a good policy in the eyes of another stakeholder. And so we go through example after example after example, go through historical vignettes to talk about the fact that there's such a thing as a good idea and good timing, but there are views of others. And the key for any good policymaker is to always understand the views of others so that you can make a fully informed policy recommendation.
Hi there. As you can tell, space is one of those branches that I'm still yet finding some deeper things about. So anyway, two quick questions. Number two, or one, you mentioned to gather a bunch of mentors. So in China, there's a saying from the Analects by the Confucius' students, 三人行，必有我师. That means out of 3 people, only 1 can be my teacher. So I would like your opinion on that, so whether you agree or disagree with some of the Chinese scholars of the past. That's 1. Number 2, opinion on drone use, whether it be warfare, civilian use, etc. I have a boyfriend who kind of sort of works around in the drone sector, by the way. Thank you.
Okay, 2 questions there. I'll be brief on those because I want to make sure we get enough time for everyone. So first off, there's a caveat to your first question. There's Eastern philosophy and there's Western philosophy. So growing up in the West, I've spent some time in Asia, specifically in China and Taiwan. I am starting this thought from a Western perspective. So from my Western perspective, my experience is more than one mentor is a good idea. I will reconcile the differences of opinions that I get from my mentors myself. So if I get conflicting guidance from one versus another, the onus is on me to figure out which of those 3 sets of information do I choose to accept as my truth, or do I blend them in some sort of way to accept all of them. So that's my philosophy, is I lean towards more is better when it comes to teachers and mentors. Your second question was on drones, not specifically my specialty, but I will say that drones are a factor, a real thing in modern warfare. They exist and they will continue to be very prevalent. There are ethical considerations that have to be unpacked with remote control warfare, if you will. There are considerations there. I mentioned before, though, that when it comes to the space community, we need more than just engineers. One of the ones I mentioned was lawyers. The lawyers will help with all of those ethical dilemmas to figure out what is okay and what is not okay. And so even within the Space Force, and I know within the Air Force, when it comes to the use of drones, the lawyers always are present and have some sort of advice to offer on what is okay and what is not okay.
Thank you. So my question is, in manufacturing, what is the difference between manufacturing on the ground and manufacturing in the space? And what specific items are manufactured in space?
So your question on manufacturing in space and what's the difference between manufacturing on the Earth and manufacturing in space. The philosophy is, if I build something on Earth to take it to space, I have the ability to do that in a 1G gravity environment, and it's going to be heavy. So if I have something large or something that has heavy metal, it's going to be heavy and it's going to require a big rocket, lots of fuel, and I can only push that out into space so far with the fuel that I have. The idea behind in-space manufacturing is the belief that if I can find certain raw materials in space. I mentioned helium-3, and I wish I could remember to answer your question more fully some of the raw materials that are out there, but they escape me right now. But I know that there's a way for you to have my contact information. I can get back to you on what some of those raw materials are. But the thinking is perhaps if I'm going to use something in space, I can bypass the idea of building it on Earth and then sending it to space only to use it further out in space and simply build it in space. And the belief is it's cheaper and logistically it makes sense. That will take time to bear out as far as whether or not that turns out to be true. As in-space manufacturing matures, we're just on the cusp of it right now, exploring this. This is very exploratory right now. We're not doing this at scale. But the belief is I can build myself a Home Depot in space for the things that I need to take from the moon to Mars. And that's the idea is, can I build it in space?
We have 2 more questions and then we're going to close out.
Now, more and more company or research institute use AI. Do you think in the future or maybe now, the job market for some position related to space science will increase, keep, or decrease? The job position. Yeah.
I think the job opportunities will increase in space. As I mentioned before, there are a number of different trends that are just beginning to emerge. In space manufacturing, in space refueling, in space repair. All of those technologies show great promise and they are just beginning. So they will continue to mature. There's other things that I haven't talked about, which include things like solar power from space, beaming down solar energy from the sun through a solar array, converting that energy into RF, and then reconverting that once it's down on the Earth. And now I have a plentiful, endless supply of solar energy. There is some promise for that technology as well. And we haven't begun to go out to Mars and out to some of the other places. So there are endless possibilities from my perspective, and which means we are going to continue to need astrophysicists. We're going to continue to need engineers. We're going to continue to need data scientists and artificial intelligence and all the things that allow us to be able to do all these cool things that we're imagining right now. So I think it's going to grow.
Okay, last question.
I wanted to first thank you so much for sharing your story and the information. Very inspiring, especially the story or your origin story of Texas family. And just for those in the DMV or, listening, are there programs or maybe the most, for those that don't have that family in the hubs of space, but a parent that sees that interest or a teacher that sees an interest in their middle school or high school or college level, is there a program now that exceeds your expectations, that maybe that 13-year-old that you once were, you wish that it was there then, like the top maybe program that you would encourage?
Fantastic question and a great way to close out. Space Camp, Huntsville, Alabama. That would be the one that I would recommend, is Space Camp in Huntsville, Alabama. There are other programs similar to that one, but that one is long-standing, creme de la creme, the pinnacle program for young, aspiring, STEM enthusiastic students who think that space is cool and want to learn more. I will also say there are many trade associations that have programs that reach out to children. One that I'm very fond of, I'll throw a shout out to, is the Aerospace Industries Association, AIA. They have a rocket camp that they put on every year. Rocketry is a thing at the high school and middle school level. These kids go into laboratories and build their rockets based on the tutelage that they receive from their instructor, and then they go out into these large fields and have these huge competitions on who can launch their rocket the furthest, the fastest, the highest, all of those things. It is a huge thing. The kids come out in astronaut uniforms, the whole nine. It's amazing. If I could get involved in it, I promise you I'd be there with my little rocket too. So it's a very cool thing. So there are rocket camps, there are rocket programs, there is Space Camp down in Huntsville, but local to this area, the one program that I am aware of is through AIA. There are rocket camps and rocket competitions. That's a fantastic way for kids to explore all about space. Space is cool, but you got to get there, which means rocketry. And that's a great way to get people started on there and stimulate their minds and get them interested and allow that to just set a fire like it did for me watching aircraft take off, set a fire, and then away they go. You're welcome.
Thank you so much for hanging out with us today and learning about the future of space. Thank you to our guests online. Thank you to our guests here in person. Lunch will be served across the hallway. Anthony's going to put up our survey because we'd love to know, what did you think of this presentation? We do share it with our guest speakers as well, so they also get some feedback while you're filling that out. I have an appreciation gift for you, Albert. Thank you so much for taking time out of your day and coming here to share your knowledge and wisdom about the future of space. It's absolutely a growing area. I see our guests here who are excited about it and have great questions. So thank you for sparking their interest and curiosity.